So, engineering mathematics preparation strategy. So, my sincere advice to everyone. So, while you are preparing important topics, you just write the important formulas to remember. What are the points to remember? For example, linear algebra. What are the topics to be expected in the GATE as well as ESC? In engineering services examination, ESC students should not skip anything. ESC students should prepare everything, because we cannot say this is important, this is not important for engineering services examination students. I mean ESC students. For GATE, we have selective topics. For example, from linear algebra, important and expected topics, system of equations and eigenvalues, eigenvectors. In these two topics, most important and most expected topic is linear eigenvalues and eigenvectors. Linear algebra. So among all topics, what you have to focus only system of equations and eigenvalues. I am saying only important topics. System of equations, system of linear equations, another one is eigenvalues, eigenvectors. So 90% we can expect problems in the GATE from these models only, eigenvalues and eigenvectors. These two are important. Suppose you have less time, you can focus on important topics. If you have time, you can touch other topics as well. But in these two, most important and most expected topic, eigenvalues and eigenvectors. Compulsory question from eigenvalues and eigenvectors, compulsory question. You should not skip that. So next is system of equations. After that, next. Differential equations topics to be prepared. I mean, important topics I am talking about. Differential equations, variable separable method, so I am writing the topics as per the priority of GATE exam. The sequential order I write the topics, you also prepare accordingly. Variable separable. After linear algebra, next you can touch, you can prepare differential equations or calculus. Equations reducible to variable separable method. Equations reducible to variable. I am writing first important topics to focus. Equations reducible to variable separable method. Next, linear differential equation. Next, Bernoulli's differential equation. So in differential equations, we have two chapters. Chapter 1, several topics are there. Among all those topics, these are important and expected. And again, these four models are important. You should not skip anything. Again, in these four models, most important and expected as variable separable and linear differential equation, most important and expected. So from the second chapter regarding differential equations, topics to be expected in the exam, I mean in the GATE, for ESC they have to prepare everything. Higher order, homogeneous, higher order homogeneous differential equations. Higher order homogeneous differential equations. Type 1, type 2, type 1, type 3 particular integrals, type 1 and type 3 particular integrals. Next, Cauchy-Euler equations. Cauchy-Euler equations. So you observe from the differential equations, the topics what I said: variable separable, equations reducible to variable separable, linear, Bernoulli, higher order homogeneous, type 1, type 3, Cauchy-Euler. From these models, compulsory 1 2 marks question will be given from these models itself. Next, let us see partial differential equations. Partial differential equations, important model is classification of second order linear partial differential equation. Next, one dimensional wave equation, heat equation, Laplace equation, important but no guarantee to be expected in the exam. My sincere advice to everyone regarding partial differential equations, this classification is most important for 1 mark. Apart from that, you just briefly review one dimensional wave equation, heat equation and Laplace equation. So sometimes we can expect those topics in the GATE exam not that much important as compared to this. Now calculus. So calculus topics to be expected: limits for 1 mark, limits important for 1 mark, next maxima and minima, maxima and minima, all topics of maxima minima. Next, definite integrals, complete vector calculus, complete vector calculus. Don't skip anything from vector calculus, complete vector calculus. So for mechanical engineering students, regarding vector calculus, most expected is Gauss divergence theorem. For civil engineering students, directional derivative, unit normal vector, gradient, divergence, these topics to be expected. But anyhow, don't neglect vector calculus. You have to prepare that vector calculus thoroughly. These are the important topics in calculus. So in probability, we cannot say this is important, this is not important. In probability, you have to prepare everything. Everything you have to prepare from probability. We should not say this is important, this is not important in probability. But for mechanical engineering and civil engineering students, the most important and most expected topic is Poisson distribution. Poisson distribution, very important and most expected topic both for mechanical and civil engineering students. And I should not say remaining topics are not important. Remaining topics are also important, but this is high chance to be expected in the GATE. As well as ESC also, Poisson distribution is most important and expected as well. And you have to prepare other topics also from Poisson, from probability. But my suggestion, highest chance Poisson distribution. Next, complex variables. Complex variables, only 2 topics, very important. These complex variables not in the syllabus for GATE for civil engineering students. This complex variables, it is in the syllabus only for GATE for mechanical, but complex variables, it is in syllabus for ESC of all branches, engineering services examination of all branches, it is in syllabus. So complex variables topics to be expected from complex variables: construction of analytic function, Cauchy's integral theorem and Cauchy's integral formula. That's it. Cauchy's integral theorem and Cauchy's integral formula. Cauchy's integral theorem and Cauchy's integral formula, these are important and expected for exam point of view. 90% in the GATE as well as ESC, we can expect problem regarding construction of analytic function, Cauchy's integral theorem and integral formula. But in these two, again most important and expected topic is Cauchy's integral theorem and Cauchy's integral formula. This is very important as compared to this, but both are important. And you have to prepare Cauchy-Riemann equations also. Cauchy-Riemann equations also important. Cauchy's Riemann equations, which includes a part of analytic function only. That includes a part of analytic function. Numerical methods. Numerical methods, important and expected topics for exam point of view. Newton-Raphson method. Newton-Raphson method. Euler's method. Modified Euler's method. Modified Euler's method. Trapezoidal rule. Trapezoidal rule. Simpson's rule. Simpson's rule means Simpson's 1/3 rule only. Simpson's rule means Simpson's 1/3 rule. So these are the topics important and expected for exam point of view. So now overall, what is the weightage? Whole weightage 13 marks, linear algebra 2 to 4 marks, and differential equation also 2 to 4 marks or 2 to 3 marks, maximum 3 marks, calculus 3 to 5 marks, and probability 2 to 3 marks, but it includes in aptitude. In aptitude also they are giving 1 mark question or 2 marks question in probability. So altogether including aptitude also probability weightage 4 marks. And moreover, calculus completed, complex variables 1 or 2 marks, mostly 2 marks question will be given. Numerical methods, for mechanical numerical methods weightage 1 to 2 marks, for civil numerical methods weightage 2 to 3 marks. Because exactly why I am saying 1 to 2, 2 to 3 marks, exactly they don't give 2 marks, sometimes 1 mark, sometimes 2 marks, sometimes 3 marks. That's why numerical methods for mechanical engineering students weightage 1 to 2 marks, for civil 2 to 3 marks. And what are the how to prepare? So my sincere advice to everyone, because in this last you have hardly 3 weeks. In these 3 weeks, how to prepare regarding engineering mathematics along with other subjects is, Non-technical, there should be around 30% of total weightage. So my suggestion to you regarding non-technical subjects, regarding time allotment, daily minimum 4 hours, including aptitude and English. I'm saying not only maths, English, aptitude, daily 3 to 4 hours you can spend for non-technical. The remaining 8 hours hardly have to prepare compulsory 12 hours. The remaining 8 hours or 8 to 9 hours, or for example 9 hours, 4.5 hour one subject, 4.5 hour other subject. So you can prepare, I think mostly by this is almost January 10th. I think most of the syllabus you might have completed. So that's why again you briefly review, go through the pages and briefly review again. And if you have any short notes, that would be quite good and it would be helpful to you right before gate exam. Because 1 or 2 days before gate exam, when you go through all short notes, you'll get complete idea what to prepare, what not to prepare. And that's why short notes is very, very important. Linear algebra. Linear algebra, eigenvalues, eigenvectors, very, very important, no? So what are the things to remember regarding eigenvalues and eigenvectors from linear algebra is, for example, you observe this 4224. Remember one thing, one matrix. Regarding linear algebra, I'm saying some of the important points to remember. For example, what is the largest eigenvalue of a matrix? Suppose you are asked to find the largest eigenvalue of a matrix. Remember one point. Sum of the elements of each column is k. Sum of the elements of each column equal to k. Then largest eigenvalue of the matrix is also k, provided the elements of the matrix are non-negative. Non-negative means greater than or equal to 0. Suppose the elements inside the matrix are greater than or equal to 0, then and sum of the elements of each column is k, largest eigenvalue is k. In the exam, the question will be asked like this: the largest eigenvalue of the matrix A equal to 4224. What is the largest eigenvalue? The elements inside the matrix are greater than or equal to 0, and you need to identify sum of the elements of first column is 6. Sum of the elements of second column is 6. So largest eigenvalue is also 6. So sum of the elements of each column is k, then largest eigenvalue is also k. Sum of the elements of each column is 6, so largest eigenvalue is also 6. One gate question was given, gate 2021, one 4x4 matrix is given, and it was given like this: the largest eigenvalue of the matrix. The largest eigenvalue of, this is gate 2021, the largest eigenvalue of is a dash. So solving the problem as per the procedure will consume time, because finding the eigenvalues of 3x3 matrix only will take time, and 4x4 matrix eigenvalues calculation you have to use the formula determinant of a minus lambda equal to 0. So by using determinant of a minus lambda equal to 0, and you have to solve that 4x4 matrix determinant, you will get fourth order equation. By solving that fourth order equation, you will get 4 eigenvalues. So my sincere advice to everyone is simply remember like this: sum of the elements of each column is 3. Sum of the elements of first column 3, sum of the elements of second column 3, third column 3, last column also 3. Sum of the elements of each column is 3, then largest eigenvalue of the matrix is also 3. Largest eigenvalue of the matrix is also 3. So remember that. So without solving as per the procedure, we can directly say. And moreover, my sincere advice to everyone, for all 2x2 matrices, if you know eigenvalues, without finding eigenvectors, directly we can get eigenvectors like this. For example, this is a 2x2 matrix. What is the formula to find eigenvalues of 2x2 matrix? Eigenvalues, if you wish to find for any matrix, formula is a determinant of a minus lambda equal to 0. A determinant of a minus lambda I. To get a minus lambda I, don't write a separately, lambda separately, I separately. To get a minus lambda I, just add minus lambda to the diagonal elements of a matrix. Just add minus lambda to the diagonal elements of a matrix. Whatever you get, that is exactly equal to a minus lambda I, just by adding a minus lambda to the diagonal elements. So now find the determinant of this matrix. What is the determinant of this matrix? 4 minus lambda into 4 minus lambda, that is 4 minus lambda whole square minus 2 into 2 minus 4. So the characteristic equation, determinant of a minus lambda equal to 0 is called characteristic equation. Its roots are called eigenvalues, also called characteristic roots. 4 minus lambda whole square formula, a minus b whole square 4 square plus lambda square minus 2ab means minus 8 lambda minus 4 equal to 0. So from this I can write lambda square minus 8 lambda plus 16 minus 4, that is 12. 16 minus 4, that is 12. What are the eigenvalues? Eigenvalues are 6 comma 2. As I told you already, lambda value 6 comma 2. You observe sum of the elements of each column is k. Largest eigenvalue of the matrix is also k. So here sum of the elements of first column is 6. So largest eigenvalue is also 6 only. That's fine. Suppose you know eigenvalues and eigenvectors, how to find, if you know eigenvalues, how to find eigenvector? For all 2 by 2 matrices, this is the formula to find eigenvectors. If lambda 1 and lambda 2 are lambda 1 and lambda 2 are eigenvalues of 2 by 2 matrix, if lambda 1 and lambda 2 are eigenvalues of 2 by 2 matrix, A, B, C, D, where B not equal to 0, then the largest eigenvalue is then the corresponding eigenvectors. Then the corresponding eigenvectors are minus b a minus lambda 1 minus b a minus lambda 2, a comma b comma c comma d. So first row first column element let it be a, first row second column element let it be b, second row first column c, second row second column d. So lambda 1 and lambda 2 are eigenvalues. So my sincere advice to everyone, without finding eigenvalues of any 2 by 2 matrix, by using this formula, it's a theorem actually but not a formula, directly we get eigenvalues. So this is the example. So this is lambda 1, this is lambda 2. So corresponding eigenvectors, let me calculate. First eigenvector minus b a minus lambda 1, minus b a minus lambda 1. This eigenvalue let it be lambda 1, this eigenvalue let it be lambda 2. This eigenvalue lambda 1, this eigenvalue lambda 2, minus b, this is a, this is b, this is c, this is d, a b c d, a b c d. So what is b? B value 2, a value 4, b value 2, a value 4. So minus b, minus b, b value 2, minus b means minus 2, a value 4. So 4 minus lambda 1, that is a 4 minus 6. 4 minus 6, that is minus 2, minus 2. So your original eigenvector, actually eigenvector minus 2 no. My sincere advice to everyone is your original eigenvector is multiplied by any non-zero real number, that should also be the eigenvector corresponding to the same eigenvalue only. Suppose minus 2 is eigenvalue. Minus 2 is multiplied by any non-zero real number, that should also be the eigenvector corresponding to the same eigenvalue. That's why let that non-zero real number, I multiplied it by c. So therefore, now c is any real number. I have multiplied it by c, c is multiplied by any real number. I will multiply c by minus 1 by 2. If I multiply c by minus 1 by 2, then one of the eigenvector is 1, 1. Just in order to get it in simple form, I brought it 1, 1 form. Second eigenvector, this is the first eigenvector. Second eigenvector, eigenvectors, let it be capital X1 and capital X2. Second eigenvector, the formula as you have earlier seen, minus b, a minus lambda 2. So a, b, c, d. So a value 4, b value 2, b value 2. So b value 2, a value 4. So minus 2, a value 4, 4 minus lambda 2. Second eigenvector, second eigenvalue 2, lambda 2 value 2. So therefore it is minus 2, 2. So as I told you already, your original eigenvector is multiplied by any non-zero real number, that should also be the eigenvector corresponding to the same eigenvalue. Your original eigenvector is multiplied by any non-zero real number, that should also be the eigenvector corresponding to same eigenvalue. In order to make it as 1, I will multiply c by 1 by 2. So if I multiply c by any real number, you can write in place of c. If I multiply c by 1 by 2, I'll get minus 1, 1. This is the eigenvector corresponding to the same eigenvalue. So this is the way for 2 by 2 we can, for 3 by 3 and higher order, how to find eigenvalues and eigenvectors. After this we will start calculus then. So remember everyone, a minus lambda into x equal to 0. If eigenvalue given, then to find the corresponding eigenvector, or eigenvector given, then to find the corresponding eigenvalue. In both the cases, use the same formula. Use the same formula to find eigenvector if eigenvalue given, to find eigenvalue if eigenvector given. In both the cases, you can use the same formula. Now we'll see, that's why remember this. We'll see an example. Suppose the matrix is A equal to 3 minus 2, 2, 0, minus 2, 1, 0, 0, 1. Suppose this is the example. So this is a 3 by 3 matrix. For this, if eigenvalue given, then to find the corresponding eigenvector, or vice versa, we can follow like this. For example, eigenvalue is minus 2. For example, eigenvalue is minus 2. So find the eigenvector corresponding to the eigenvalue minus 2. What the formula I said just now? The formula I gave, a minus lambda into x equal to 0. So use this formula to find eigenvector if eigenvalue given, or vice versa. So lambda value minus 2. If I take lambda value minus 2, then it is a minus of minus 2, a plus 2i. A plus 2i into x equal to 0. To get a plus 2i, just add plus 2 to the diagonal elements of a given matrix. Add plus 2 to the diagonal elements of given matrix. 3 plus 2, 5, minus 2, 2. 0, minus 2 plus 2, 0, 1. 0, 0, 1 plus 2, 3. Just add plus 2 to the diagonal elements of given matrix so that you can get a plus 2i. Capital X is, it's an eigenvector, let it be x1, x2, x3. This is an eigenvector. Because eigenvector we don't know, so therefore that's an eigenvector. Reduce this matrix to echelon form. To reduce this matrix to echelon form, first row, first element selected, below zeros. So last row we can make zeros. Make as many 0 rows as possible. So third row minus 3 into second row. Reduce that matrix to echelon form. Third row minus 3 into second row. This is 5 minus 2, 2. 5 minus 2, 2, 0, 0, 1. Third row minus 3 into second row. 0 minus 3 into 0, 0 minus 3 into 0, 3 minus 3 into 1, 3 minus 3 into 1, 3 minus 3 is 0. This is an eigenvector x1, x2, x3. So we have to find x1, x2, x3 values. That's an eigenvector. Now first equation, tell me 5x1 minus 2x2 plus 2x3. First equation is of 5 into x1 minus 2 into x2 plus 2 into x3 equal to 0. This is the first equation. Second equation 0x1 plus 0x2 plus 1x3 equal to 0. 1x3 equal to 0. This is equation 1. This is equation. So substitute x3 equal to 0 in equation 1. So equation 1 implies that 5x1 minus 2x2 plus 2x3 equal to 0. Plus 2x3 equal to 0. x3 value 0. So from this 5x1 equal to 2x2. From this, what is x1 by x2 value? From this x1 by x2 equal to 2 by 5. From this x1 by x2 equal to 2 by 5. I mean x1 value 2, x2 value 5. x1 value 2, x2 value 5. x1 value 2 and x2 value 5. x1 value 2, x2 value 5, x3 value 0. That's an eigenvector. Therefore, the eigenvector corresponding to the eigenvalue is x1, x2, x3. x1, x2, x3 values 2, 5, 0. x1, x2, x3 values 2, 5, 0. So now you observe x1, x2, x3 values 2, 5, 0. So therefore, if eigenvalue given, this is the way we have to find eigenvector. The only thing we have to remember is, once you have found a plus 2i value, reduce this matrix to echelon form. After reducing the matrix to echelon form, each value can be found separately. So I teach a different technique, which is an alternate. See, same problem can also be done in different way as well. You can try, or you can remember this way also. So what is the given matrix? Tell me. 5 minus 2 given matrix, 3 minus 2, 2. 3 minus 2, 2, 0 minus 2, 1, 0, 0, 1 I think. 0 minus 2, 1, 0, 0, 1. So reduce the matrix to this. What is the corresponding eigenvalue? Corresponding eigenvalue lambda equal to minus 2. So substitute, after substituting lambda equal to minus 2, after substituting lambda equal to minus 2, you will get this one only, no? Substitute lambda equal to minus 2 here. Lambda equal to minus 2, minus into minus 2 plus 2. So to get a plus 2i, just add plus 2 to the diagonal elements, we get this. This is the matrix we have to consider, not this. What is this? 5 minus 2, 2, 0, 0, 1. 5 minus 2 to after substituting lambda value minus 2, 5 minus 2 to 0, 0, 1, 0, 0, 3. Now select any two different rows. To find the eigenvector corresponding to the eigenvalue, select any two different rows. After substituting a minus lambda I, after substituting lambda value in a minus lambda I, substitute. Now once we get a minus lambda I value in this matrix, select any two different rows. Select two different rows. Select two different non-zero rows. Select two different non-zero rows. Select two different non-zero rows. Second and third rows will not be different non-zero rows, because if third row is divided by 3, you will get second row only. That's why second row and third row will not be different non-zero rows. Only first and second are two different non-zero rows. Now this is the way you remember. First row, start from middle number minus 2 to 5 minus 2. Start from middle number and move in anti-clockwise direction. Minus 2 to 5 minus 2. What I said? Start from middle number and move in anti-clockwise direction and complete one cycle. So I start from middle number minus 2. From here go in anti-clockwise. 5 minus 2, 5 minus 2. Minus 2 to 5 minus 2. Similarly, third row, second row, start from middle number and move in anti-clockwise direction. 0, 1, 0, 0. 0, 1, 0, 0. After adding plus 2, that is the... So now between these two columns, insert x1. Between these two columns, insert x2. Between these two columns, insert x3. Insert x3. Now these two product divided by these two product. So x1 value I am saying x1 value x1 by x1 denominator, these two product minus these two product, that is minus 2 into 1 minus 2 minus 0 into 2 0. So minus 2 x2 divided by next these two product minus these two product. These two product, determinant of this matrix, these two product minus these two product, 2 into 0 0 minus 1 into 5 minus 5. Next x3 by x3 value lies between these two columns. So treat it as one 2 by 2 matrix. So find the determinant of this 2 by 2 matrix, that is these two product. Determinant of this 2 by 2 matrix is these two product and these two product, that is 5 into 0 minus 0 into minus 2, ultimately it is 0 only. So therefore we got x1, x2, x3 values, let it be C. Let it be C. Say. So x1 value minus 2 into C, minus 2C, x2 value minus 5 into C, minus 5C, x3 value 0 into C, 0. So the eigenvector is x1, x2, x3 equal to, as we have seen just now, minus 2C, minus 5C, 0C. So in order to eliminate minus sign, C is C, because your original eigenvector is multiplied by any non-zero real number, that should also be the eigenvector corresponding to the same eigenvalue. That's why our original eigenvector actually minus 2 minus 5 0, that is multiplied by C. Now to convert that minus sign as plus sign, multiply your original eigenvector by minus sign. Minus into C equal to minus 1. C equal to minus 1, minus 2 into minus 1, minus 5 into minus 1, 0 into minus 1, 0. Therefore, what is the eigenvector? 250. 250 I did in this manner. So earlier we got eigenvector earlier also 250, but what we did is after writing A minus lambda I, that A minus lambda I matrix was reduced to echelon form. After that each value separately we found. This is the procedure of finding eigenvector. This is the technique of finding eigenvectors. This is the way we can solve problems regarding eigenvalues and eigenvectors. Now let us see calculus. Calculus most important and most expected topic. This is GATE 2024. Limit x square minus 2ax, limit x square minus 2ax plus b divided by x minus 1 as x tends to 1 equal to 8. As x tends to 1 equal to 8, then a minus b equal to dash. So question is, suppose limit x square minus 2ax plus b divided by x minus 1 as x tends to 1 equal to 8, then what are the values of a and b? This is the question. And once you get the values of a and b, then what would be the value of a minus b? That's fine. So GATE 2024 it was given. Now you observe, if I take x equal to 1, then it becomes 1 minus 2a plus b. By denominator 1 minus 1, 0. Your doubt is, sir, something by 0 is infinity. So infinity equal to 8. Infinity equal to 8, it's meaningless. Infinity equal to 8, it's meaningless. So that means I am saying without knowing a value and b value, how would you say that something by 0 is infinity? Because for some particular values of a and b, for some particular values of a and b, if this numerator becomes a 0, in case numerator becomes a 0, then it is 0 by 0 by putting x equal to 1. 0 by 0, after applying L'Hospital rule, there is a chance that it becomes, resulting answer is a finite number, that finite number equal to 8 in that case then. So that's why in order to make resulting answer is finite number, so first you write like this, limit x tends to 1, numerator is x square minus 2ax plus b by x minus 1 equal to 8. So if I take x equal to 1, then it becomes 1 minus 2a. 1 minus 2a plus b divided by denominator 1 minus 1, 0. Denominator 1 minus 1, 0, 0 equal to 8. So your doubt something by 0 infinity, 8 equal to infinity, which is meaningless. But you don't know a value, b value. Without knowing a value and b value, we cannot say something by 0 is infinity. Because for some particular values of a and b, in case numerator 0, it becomes a 0 by 0. So after applying L'Hospital rule, there is a chance that it can become a finite number. It can become 8. So that's why the chance it should be finite is only when numerator 0. So that's why 0 into 8, 0. So numerator is 0. That is 1 minus 2a plus b equal to 0 into 8, 0. So this is equation 1. Actually, we were asked to find a minus b. We did not get a minus b value. We got 2a minus b equal to 1, but we did not get a minus b. That's why Let us do one thing, find b value from this b equal to 2a minus 1. From this b equal to 2a minus 1, substitute b equal to 2a minus 1 in equation 1. After that we think what to do. Substituting b equal to 2a minus 1 in equation 1. So equation 1 implies that limit extends to 1, x square minus 2ax plus b. Numerator x square minus 2ax plus b, b value 2a minus 1. B value 2a minus 1 divided by x minus 1 equal to 8. So if I take x equal to 1, it becomes a 0 by 0 form. If I take x equal to 1 here, then it is 1 minus 2a. 1 minus 2a plus 2a minus 1. 1 minus 2a plus 2a minus 1, numerator 0. So denominator 1 minus 1, 0. So by applying, it is 0 by 0 form. Apply L'Hospital rule. Applying L'Hospital rule means differentiate both the numerator and denominator with respect to x. Numerator x square derivative 2x minus 2a into x derivative 1 plus 2a minus 1 derivative with respect to x 0 divided by denominator x minus 1 derivative with respect to x 1. So 2x minus 2a divided by 1 equal to 8. So take x equal to 1, 2 into 1 2 minus 2a equal to 8. So from this minus 2a equal to 8 minus 2 6. So therefore from this a equal to 6 by minus 2. From this a equal to 6 by minus 2, 6 by minus 2 is minus 3. So a value minus 3. Not only a value, we have to find b value as well. So b equal to 2a minus 1, substitute there, you will get b value as well. B equal to 2a minus 1. B equal to 2a minus 1. If I take k value, minus 3, minus 1, minus 6 minus 1, minus 7. So what we were asked to find? A minus b. So therefore a minus b equal to, what is a value? Minus 3. A value minus 3 minus b value minus 7. So minus of minus 7 plus 7, 7 minus 3, 4. Therefore a minus b value 4. A minus b value 4.